Hello everybody, is the audibility fine? Shall I start today's class? Am I audible to each and every one of you? Great, well done. Rest of the people, is the audibility absolutely fine? Am I audible to all? Shall we start the class? Right? Great. So I think we should. So the audibility is absolutely fine. I think we should start the class. Great. Nice. So all those people who are avid follower of this channel, so probably those people who have watched the video yesterday as well, that was my first class, and in the very first class we have discussed two concepts. The first was to find the number of zeros at the end, and the second was to find the unit digit value. And today in the morning I have shared this PDF, and this PDF has got 120 questions and we will be discussing almost all of them, right? So I do believe that I have shared this PDF in the Telegram channel. So the Telegram link will be shared to you by sir, and what you can do is you can straight away go to the Telegram channel and you can download this PDF. Fine? Shall we start? Great. Before starting the class, I want each and every one of you to write this in the comment box. Yes, I have already shared this. Yes, I have already shared this. I have already shared this particular PDF in the Telegram channel. The link has been provided to you, and that is Saurabh sir official. You can go to the Telegram channel and you can download this, right? Right. So before starting today's class, I want the people to write right at the top of the copy, and that is one life, complain less. One life, do more. One life, live more. So if it is just a one single life, then there is no point complaining. In the pursuit of what we want, we should be thankful to what we have. Gratitude, humility, these are important traits. Whatever you are pursuing, whatever your dream is, whatever your aspiration is, in that process, we should be thankful to what God has given us, because there are many people who even don't have this. So, every single day we cannot complain about the things we don't have. There are many people, for them, the things which you possess, they are luxury. So let's write this. One life, complain less. One life, do more. One life, live more. And let's start today's class. Is everybody ready? Shall I start today's class? Shall we start today's class? Great. I think we should, and I think let's start the class. So as I told you, in the yesterday's class, in the last class, we had a discussion on unit digit value and number of zeros at the end. In today's class, we will be doing this. This will be the third topic, right? So we are discussing general aptitude. We are discussing general aptitude. And the very third topic would be, I'm already done with first topic, second topic, and let's start the third one. So the third topic is to find the last two digits. To find the last two digits, this will be the third topic. Sir, has IIT or has GATE ever asked question from this topic? No, they haven't till date. But I am assuring you they will going to ask a question from this particular topic, and they're going to ask this question, they will going to ask you a question very, very soon, right? What you can expect from this topic? Once I am done with this, if you are asked what is the last two digit of this, you will be in this position. Even if you don't have the PDF, it is absolutely fine. Please focus over here. So if you are asked what is the last two digit, in this case 21 to the power of 23, you will be in this position to answer this. If you are asked 3 to the power of 25, what should be the last two digits? You will be in this position to answer this. If you are asked 9 to the power of 29, and similarly if you are asked 7 to the power of 23, 2 to the power of 37, you will be in this position to answer these questions. Is it fine? Right? 5 always gives 5, 6 always gives 6. I told this yesterday in last class. 5 to the power of 1 is 5, 5 square is 25, 5 cubes 125, 5 always gives 5, 6 always gives 6. I have told this in the last class, right? So these are the things which we are about to discuss. Great. And how we are going to approach this? Just for better navigation, I am telling you this. What is that? We are about to discuss this topic like this. This is not a standard bifurcation, but what I have done, I have divided this topic in 2 different categories. What kind of categories? Those cases where the unit digit value is 1, right? And the second one is when the unit digit value is not equals to 1. So the first case is when the unit digit value is equals to 1 and when the unit digit value is not equals to 1. This is not a standard bifurcation. This is the bifurcation I have created just for the sake of ease so that we can understand the topic. That is it. So once I am done with this particular topic, you will be and you should be in this position to answer these kind of questions. If someone asks you 23, 21 to the power of 23, you definitely can answer the question. 31 to the power of 99, you would be in this position to answer these kind of questions. Fine. And after this, even if you don't have the PDF, focus what I am saying. And after that, you can share. I will share it once again. Don't worry about it, right? And then after this, we'll be discussing these 2 topics, these 2 cases. When the unit digit value is equals to 3, 9 or 7. And finally, we'll be discussing those cases when the unit digit value is equals to 2, 4, 8 and 8 or 6. These are the cases we're going to discuss, right? Once I am done with this, you should be in this position to answer these kind of questions. And you will be in this position. This is for sure. And after this, you will be in this position to answer these kind of questions. So this is how we're going to approach. We are about to discuss how to find the last 2 digits and we will be approaching this particular topic in this way. The very first case would be when the unit digit value is equals to 1. This is not a standard bifurcation. I have bifurcated it just for the sake of ease so that we can have a better navigation, right? And the second one is when the unit digit value is not equals to 1. So what is that? 397. Sir, am I supposed to write it? Yes, absolutely. Whatever you believe is important to you, do write all those points. I think we should start. Let's start with the first one. This is the topic I am about to start with, right? Let's go ahead. We are to find the last 2 digits, L2Ds, last 2 digits, when the unit digit value is equals to 1. Absolutely. This is what we are about to find. Great. So what is the question? The question is this. If the question is 21 to the power of 23. Even before starting this, a small disclaimer is to all those people who have attended yesterday's session. I have discussed what I have discussed to find the unit digit value. That part is done and dusted. Fine. That part is no more required here. We have discussed power cycle. Power cycle can be used only to find the unit digit value. We are here to find the last 2 digits, units place and tens place, right? So whatever we have discussed yesterday, that part is done and dusted. So how am I supposed to find? First of all, we are not interested to find the exact value. What we are supposed to find? The last 2 digits. Whenever there is 1 at the units place, take this 1 and drop this. This is the first step. This is the first step. Fabulous. This is the very first step. So what is the first step? Take this 1 at the units place and drop it. That's it. And the second step is take this digit at the tens place and multiply this with another digit which is there at the units place. And multiply these 2 numbers. 2 into 3 and this is the answer. That's it. That is it. Take this 1 at the units place and drop it and Furthermore, take the number at the tens place, consider the number which is present at the tens place and multiply this number with the number which is present at the units place. Although it is difficult to believe, but it is absolutely correct. 11 square, what we know is 121, right? What I am suggesting is drop this one, 1 into 2. What is this? 21, exactly the same answer. Similarly, 21 cubed, this is 9261. What I have suggested? I have suggested this. Take this units place and drop it. Multiply this tens place with this units place. That's it. 3 into 2 is 6 and this is the answer. Sir, what will going to happen if what? If I have a number like this, 21 to the power of 98. Sir, what will going to happen in this case? We can take this one and we can drop it like this. That we should always do. If there is one, drop this. 8 into 2 is 16. So this is 6. Great. Absolutely perfect. Shall I give you 2 questions? I think I should. So this is 31 to the power of 9, 9, 8, 7. And the second question is 51 to the power of 2, 3, 4, 6, 9. I want the people to find the last 2 digits. That is it. Please find the last 2 digits in both these cases. Great, well done. Each and every one of you must find the answer. So what is the answer? The last 2 digits we need. Great. Drop the units place and multiply the tens place with the units place. That's it. Right? Great. So this is 1. We can drop this 1. This is 3 into 7. What is 3 into 7? 21. So what am I left with? 1. So this is the answer, 11. Great. This is 1. We can drop this 1. This is 5. 5 into 9 is 45. So what should be the answer? The answer is 5. Great. Well done. So this is the pattern. Great. If let us suppose if this question is like this and the power is like this, what are we supposed to find? The last 2 digits, and that is why we should only be concerned about the last 2 digits. Here we are supposed to find the last 2 digits, and that is why we should only be concerned about this. Sir, you mean to say that both these values are equal? No, it is not possible. But here we are concerned only about the last 2 digits. And therefore the answer is, we can take this one, and this is 8 into 4 is 32, and this is the answer. Sir, you mean to say that if the question would have been like this, 2, 3, 4, 5, 6, 1. 1991, 1992. What should have been the answer? What do you think? What is the answer? Well done. That's it. That is it. Absolutely correct. Absolutely correct. So this is the answer. First of all, this question is as good as 61 to the power of 1991, and this is 992. Right? And if this is the case, we can take this one, just drop this one. This is 9 and 6 into 2 is 12. So this is the correct answer. Fine. It's clear? Great. Absolutely correct. Let's move on to the next one. Let's move on to the next one. To find the last 2 digits, when the unit digit value is 3, 9 or 7. To find the last 2 digits when the unit digit value is 3, 9 or 7. Right? Now listen to this. I am a very strong admirer of a few authors, especially self-help books like Jim Rohn, Brian Tracy, Tony Robbins, Napoleon Hill, Les Brown, all these people. And other than these authors, I am a very strong admirer of, I am a very avid follower of Jim Collins as well. If you have heard of this person, Jim Collins, if any one of you who love to read about different companies, how different organizations were actually, different organizations were formed. Jim Collins has written 4 different books. Till date, he has written 4 different books. How the Mighty Fall, Built to Last, Good to Great, and Great by Choice. Every single book is just incredible. For example, what Mr. Collins and his team does is this. They take a huge pool of companies and they compare all those companies. Excuse me. What makes these companies really outstanding? What are the attributes? What are the features? Why these companies are one of its kind? Be it Google or Coca-Cola or although AMD and Intel processor, but Intel processor I should say, Walmart, and they have named these companies great companies. And then there are good companies. And he has mentioned that the difference between good companies and great companies is this theta. And what is this theta? This theta is fanatic discipline. Fanatic discipline. What is fanaticism? This is PLIN. What is fanaticism? Fanaticism is extreme passion, just like Sam Walton had. For which company Sam Walton had established? Walmart. When Sam Walton was in his 60s, he was arrested in Brazil because he was in one of its competitors' complex. He was actually measuring the aisle distance and he was trying to find out how these display look so good. What else I can do in my Walmart? And this guy got arrested. Think about the person at the age of 60, he still wanted to improve. Sam Walton once said, I don't just want to become rich, I want to be the best. There are different kind of people who are driven by different kind of emotions. Sam Walton was one of those people. And there is one more thing which was written just beneath this, and what is that? Good is the enemy of great. I want you people to write this. And always remember this. Good is the enemy of great. Good is the enemy of great. What does that mean? Whatever you will going to learn from here, whatever you are going to achieve in your life, we should never get complacent. Humility, humbleness, those things are very, very important. Steve Ballmer is a great speaker, but at the same time, Bill Gates is an outstandingly brilliant speaker. And what differentiates these two people? When Steve Ballmer enters to any stage, he excites the crowd so much, the entire crowd gets excited. And you can see they are pumped up. But when you get motivated like this, that motivation lasts for a very small duration of time. Then there is Bill Gates, who is extremely voluble speaker. The way, the suaveness with which he conveys his message is entirely different. But whatever he says stays with his audience. That is a fascinating level of speaking. That's an outstanding, brilliant way of speaking. Right? Good is the enemy of great. Do remember this. People get complacent very easily. So in all his books, and there are a few more books actually, The Purpose by Howard, a professor from Harvard, I forgot his name. And then there is one more book, it's not what you sell, it's what you stand for. In all these books, you may come across a word, and what is that? Purpose, objective. In aviation sector, it is very, very difficult to make profit. In the past 35 years, there are more than 1,400 companies who entered into aviation sector. There are certain sectors where the entry is very easy, but the exit is very difficult. And in that kind of market, the world's most profitable airlines still is Southwest Airlines, SWA. And why is that so? Because they have decided, and the mission was, let's democratize the sky. and whatever it takes, let's democratize it. It's an unbelievable level of mission and vision. And for this to happen, to democratize the sky, they did the needfuls, whatever was required. Similarly, Walt Disney said, the objective of my existence, I want to bring happiness into people's life. BMW said, forget about engineering. Who cares about engineering, man? When a person drives BMW, the person should feel the zest. That should be an exhilarating experience. I want to sell, I want to provide that zest, that exhilarating experience to the customer. This is an unbelievable level of mission. You know why all these business leaders do this? Anyone who knows this? Because our brain is conditioned like this. These are the three circles of our brain. And what happens, even in our school days, our teacher and many people whosoever we come across, they told us read books, right? But we avoid that, right? And why is that so? Because this circle understands what, this circle understands how, and this circle understands why. This is neocortex. Similarly, our brain, in case of our brain, it is called neocortex. And these two layers are called limbic. This is limbic part of the brain. All the calculation, the numbers, the database, the understanding, it takes place at this place. Listen to this very, very carefully. And the decision which we take from our gut. Someone asks you like, how have you come to know that you should take this decision? I don't know. I've taken that decision just from gut, deep down my heart. All those decisions which you take from your gut, more often than not you get the correct answer. Why? Because these two layers understand that. And every single time in our past, when our teachers and whosoever person we have come across, they said what we should do, we were not concerned. How we should do, we were not concerned. And they were not concerned to tell us why. And what the most influential people, 1963, Martin Luther King Jr., he conducted a seminar in Washington, D.C. You cannot believe millions and millions of people attended the presentation, attended the seminar. The era of no Google, the era of no WhatsApp, the era of no Facebook. 1963, Martin Luther King Jr.'s seminar was attended by a huge gargantuan number of people. Why is it so? Because their why was clear. These companies, let's democratize the sky, their why was clear. I want to bring happiness into people's life, Walt Disney, their why was clear. Forget about engineering. I want to sell passion, zest, exhilaration in people's life. BMW's vision, this why was clear. And that is why all those people who have a strong why, they are the most esteemed leaders. They are the leaders who have actually recorded, they've registered their presence in history. My point is, what is your why? Why you want to prepare? And that is why in the last class I said, your why must be bigger than your no. If you don't have a why, either today or tomorrow or day after tomorrow, each one of us, in whatever journey we are actually in, we will stop that journey. This why is very important. We need to find our why, and that is very personal. Sir, I want to do this. I want to go to the best B schools in India because I just want this. That's my dream. That's my aspiration. Sir, I want to achieve this for my mother. I want to achieve this for my parents. I want to see them feeling proud of me. Whatever that is extremely personal. But that, without this why, it's very difficult, because every single journey of yours, you will definitely go through tough times of life. And when you are actually going through those tough times, you need this why. Because this why will bootstrap you out of those tough times. That is why is required. Let's go ahead. Is it fine, everybody? Great. So, let's start this. So my point was, I just wanted one word, and what was that? Objective, the purpose. That was the word I was looking for. I just want this one word, right? So I told you in yesterday's class, I'm not here to teach you anything. You and I will create revolution. This is my promise. I cannot create revolution all alone, but you and I, we will create revolution. This is my promise to you, right? So fine, let's start this. Sir, why you were telling all these things? I am a GATE aspirant. It's a very innocuous, very harmless, very sophisticated, very juvenile question. So why I have told all these things? Because I wanted this word. What word? Purpose, objective. I was looking for this word. So this is the objective. So in case of finding the last two digit, when the unit digit value is 3, 9 and 7, the objective will be, so this is the objective, right? So I was looking for this word, that's it. I needed this word objective. This is the most important word. This is the most important word, objective. We need a very strong purpose. We need a very strong and deep purpose so that you can actually fight through, you can actually sail through. So the objective is, what is the objective? The objective is try to make one. How can we make one? How can we create one? Why this? Because 3 to the power of 4 is 81. So we can have one. 9 to the power of 2 is 81. Again we can have one. And similarly, 7 to the power 4 is 2401. Sir, but why are we concerned about 1? You want to know the answer philosophical or literally? If you want to know the answer literally, in that case, because we have already discussed 1 and 1 has got phenomenal power. How come? Because we have already seen the power of 1 and this is the power of 1. Each and every question where unit digit is 1, we can directly drop the unit digit and we can multiply tens digit with the units digit and we'll get the answer. And that is what happens in these cases. 3 to the power of 4, 9 square and 7 to the power of 4. Great. In that case, sir, if we have this question, 3 to the power of 23. First of all, from GATE's perspective, it's a very good question. From GATE's perspective, it is a very, very good question, right? So 3 to the power of 23, the objective is make 1. That's the whole objective. In case of 3, 9 or 7, make 1. That's the objective, that's the purpose, that's the goal, that's the mission, vision, whatever you want to say. So, what I have done? I have written 3 to the power of 4. But when I have written 3 to the power of 4, forget about the power cycle. That part is done and dusted. We are already done with this. Power cycle is used to find only what? Only unit digit value. That's it. And if this is the case, let's do this. Fabulous. What is 3 to the power of 4? 81. This is 5. This is 27. Great. Here we are concerned only about the last 2 digits. Fabulous. And if this is the case, what we can do, we can drop this one. We already had a discussion on this. 8 into 5 is 40, so this is 0. 27 into 0, 1. The answer comes, excuse me, the answer comes out to be 27. Is it fine, everybody? Is it clear to all? Is it clear to each and every one of you? Right? Great. Well done. I think this is absolutely clear, right? So what is the objective? Sir, you mean to say that only this part, what part? The objective part is important. Absolutely. Whenever you come across this number 3, whenever you come across the number 9, whenever you come across the number 7, what is the objective? Make 1. Finish. That's it. So 3 to the power of 4. 5 times. What is that I am left with? I am left with what? I am left with the remainder part. And what is that? That is 3 cube. That's it. If this is the case, if you have understood this, please find the answer of this particular question. What is the question? 3 to the power of 37. Please find the last 2 digits. Please find the last 2 digits. Three to the power of 37, last 2 digits, please. I'll take a few more examples. Sumant Kumar Arya, I'll take that. Don't worry. 3 to the power of 37. Great. Well done. Great. Fantastic. So, how am I supposed to start? Why I am not considering 5? I'll let you know. 3 to the power of 4, 9 times. This is 3 to the power of 1. 9 into 4 is 36. What is that I am left with? I am left with 3 to the power of 1. So, what is the answer in this case? This is 81, this is 9, this is 3. After this, take this one and drop this. And 8 into 9 is 72. So, this is 2. This is 3. So, 21 into 3 is 63 and that is it. Sumant, is it fine? Absolutely. Whatever Vishnu has written is absolutely correct. Because 5 will always going to give 25. Absolutely correct. That is the reason. What Vishnu has written is absolutely correct because 5 will always give last 2 digits as 25. Is it fine, everybody? Shall we proceed further? Great. Absolutely. Shall I take one more example? So, another example is 3 to the power of 41 plus what? 51 to the power of 44. Go ahead. Sumant, I want answer of this question. The question is 3 to the power of 41 and 51 to the power of 44. Sumant, I want your answer. Right? Go ahead. So, what is the answer? Well done. Great. Fantastic. Absolutely correct. Nice. Great. Let's move on. So, this is 3. Those people who still find it difficult, absolutely fine. We can discuss this. So, this is 3 to the power of 4 and this. So, what is 3 to the power of 4? 3 to the power of 4 is 81. This is 10. This is 3. Great. What we can do? We can take this one and we can drop this. 8 into 0, this is 0, this is 3 and this is 0, 3. This is not the final answer. The final answer would be after adding this. This is 51, so what we can do is we can drop this one. 5 into 4 is 20. Great. So what is the answer? The answer is 0, 3 plus 0, 1 and hence the answer is 0, 4. Is it fine, everybody? Sumant, now is it fine? I think it is clear. So I do believe it is absolutely fine. Great. Shall we proceed further? Let's move on. Last 2 digits, Mukul, 0, 4. After 3, let's find the last 2 digit, 3, 9, 7. After 3, let's move on to this 9. Great. So after 3, let's take this 9. 9 is actually elder brother of 3. How come? Because if the question is, see, the idea is, since yesterday we have been discussing a very specific concept, and what is that? Whatever we have discussed yesterday and even today, that is actually cyclicity. And what is that? We are trying to form a pattern. Right? So what is cyclicity? Something that repeats itself. Like, let's take one example from economy. Although I have drawn this in a very layman language, but this is how an economy works. This is called a business cycle or a T cycle. T, it means a trade cycle. This is called a business cycle or a trade cycle. So what does this very first phase? This very first phase is called growth phase. This is growth phase. What is this? This is the recession phase. Right? 2008, 2009, the world entered in this phase and we actually went through this. This is the depression phase. 1929, United States, Great Depression. And this is recovery phase. and this is recovery phase. And after this what happens? This cycle keeps on repeating itself, right? And right now where is the world? The world is somewhere here. So my point was, this is cyclicity. This is what cyclicity is. Something that repeats itself, right? Fine. So let's take another case. The case is 9 to the power of 23. What we know, in case of 3, 9 or 7, what I have told you earlier, I have told you this. What was that? In case of 3, 9 or 7, the objective was, we'll make 1. That's the objective. 3 gives 1 when there is power, when 3 is raised to power 4, 3 to the power of 4 is 81, and 9 to the power of 2 is also 81. And if this is the case, I want a different color. And if this is the case, 9 square, 11, and this is 9. Great. Absolutely phenomenal. This is 81, 11, and this is 9. So this is 1, 8, 9, 7, 29. So answer is 9. Absolutely. Is it fine, everybody? Is it clear to all? Absolutely correct. So the answer is 29. Shall we take another example? Of course we should. Let's take one example. I want you people to find the last 2 digits in case of 9 to the power of 31 plus 51 to the power of 99. Go ahead. 9 to the power of 31 and 51 to the power of 99. I want you people to find the last 2 digits. 9 to the power of 51 and what is the 31 and 51 to the power of 99. Nine to the power of 31 and 51 to the power of 99. Great. Nice. So 9 to the power of 31. So this is 9 square 15 times and this is 9 to the power of 1. Great. What is 9 square? 81. This is 15 and this is 9. So what we can do is we can drop this one. 8 into 5 is 40, so 0 and this is 9, so this is 0, 9. This is not the final verdict. This is not the final answer. The final answer will be this. We can take this one and we can drop this. 9 into 5 is 45, so this is 5. 51 plus 0, 9. So what should be the answer? The answer is 60. Is it fine, everybody? Is it clear to all? Is it absolutely clear to each one of you? Fine? Great. Well done. Shall we move ahead? Let's take the another one. Right. 7 to the power of 23. If we are to find the last 2 digits in case of 7 to the power of 23, see, the objective remains the same. In case of 3, 9 or 7, what was the objective? The objective was to find, to make 1, to create 1. That was the objective. And if this is the objective, let's make 1. How come we make 1? 7 to the power of 4 is 2401. So if you want to create 1, we should open this like this. Because 7 to the power of 4 is 1. So that's why. Right? What are the last 2 digits? 0, 1. So this is 0, 1, 5. What is 3 cube? 3 cube is 343. I am not concerned about that. So what we should be concerned about? The last 2 digits. That is what we are discussing. So the answer is 43. But I think there is one more thing we can see. And what is that? If you observe this closely, I'll take new color. Then what you can see? If you observe this closely, especially this part, there is barely any contribution of this part. there is barely any contribution of this part. What does that mean? What does that mean? It means that anyways this part will going to give me 0, 1. And whatever number is multiplied with 0, 1, you will get the very same answer, right? So, if this is the case, why should I solve this? So, it means we can directly divide this 23 by 4, and after that, what is that we are left with? The remainder part, 7 cube. And what is 7 cube? 343 is 43. So, you mean to say that if the question is 7 to the power of 21, 7 to the power of 22, 7 to the power of 23, 7 to the power of 24. If these are the questions, then you are saying that directly divide this number by 4 and you should only be concerned about the remainder part, and the remainder part is 7 to the power of 1. So, what is 7 to the power of 1? 0, 7. You should divide this by 4, so this is 7 square, and what is that? 49. You should divide this number by 4 and 7 cube is the number we are left with, so this is, and this entire number gets divided, so the answer is 0, 1. Is it fine, everybody? Is it clear to all? Is it absolutely clear? So, 7 is considered to be the most important number when you are supposed to find the last 2 digits. More often than not, whether it is in CAT or in different competitive exams, wherever they have asked the last 2 digits, more often than not, they have asked 7. Is it fine? So, 7 is very, very important. Shall we take an example? Fine, let's take an example. 7 to the power of 81. If you are to find the last 2 digit in this case. Second, let's take one more example. 7 to the power of 1991. Great. Plus 61 to the power of 2009. 2009. That is it. We need to find the last 2 digits. Go ahead. You are to find the last 2 digits. Great. And you are to find the last 2 digits in both these cases. Go ahead. Nice. Great. Well done. I think we should discuss. The last point was, because in case of 7, this part does not make any contribution. That is why we should only be concerned about the remainder. So, when you are dividing the power by 4, just check the remainder part. That's it. That was the last point. 20, when you divide 20 by 4, the remainder is 1. And the 7 to the power of 1, the answer is 0, 7. When you divide 22 by 4, the remainder would be 2. 7 square, 49 is the answer. When you divide 23 by 4, you will get 7 cube, that is 343. Fine, let's discuss both these questions. So, this is 81. When you divide 81 by 4, the remainder would be 1. And hence the answer would be 0, 7. That's it. You won't believe the question which was asked in CAT was 7 to the power of 2008, and exactly the very same question was asked in Vizag Steel as well. What is the answer? If the question is 7 to the power of 2008, what should the answer be? If the question is 7 to the power of 2008, what should the answer be? Great, absolutely. If the question is 7 to the power of 2008, we can directly divide this 0 by 4, and hence the answer would be 0, 1. That's it. So, more often than not, you will come across this question because this question was asked in CAT way back. It was asked in CAT, and after that, it was asked in Vizag Steel as well. Fine. Let's come back to this one. 7 to the power of 1991. 1991 was the year in which India liberalized its market. What we went for? We went for liberalization. And after that what happened? After that, many of the MNCs, they come to India. So whatever multinational brand product you have been using for the past so many years, it actually happened post 1991 after liberalization. So fine. So 1991, when you divide this number by 4, we can get 7 cube. What is 7 cube? 343, and that is why it is 43. Right? This is 1, and we can drop this 1. 6 into 9 is 54, and this is 41. So 43 plus 41 is 84. That is it. Is it fine, everybody? Is it fine? So these are the cases where we were to find the last 2 digits. We are already done with last 2 digit in case when the unit digit value is 1 and when the unit digit value is 3, 9 or 7. That's it. Fine. Let's move to the last segment. If we are to find the last 2 digits when the unit digit value is 2, 4, 8 or 6. As I have told you earlier as well, what is that we have discussed earlier? What we are discussing in this case is a pattern, a cyclicity, right? So cyclicity is what we know, 2 to the power of 10 is equals to 1024, and this 24 has got a pattern to it. What kind of pattern? 24 to the power of odd and 24 to the power of even. What in case of 24 to the power of odd, 24 to the power of 1 is 24. 24 to the power of 3 is 13824. In case of 24 to the power of odd, last 2 digits will always be 24, and in this case the last 2 digits would be 76. And the last 2 digits would be 76. Till now what we have discussed, we have been discussing cyclicity, we have been discussing pattern, right? So 24 to the power of odd, 2 to the power of 10 can give you 24, and 24 to the power of odd is always, the last 2 digits are always 24. On the contrary, 24 to the power of even, last 2 digits always 76. That is it. If this is the case, at least we got an idea. If the question is 2 to the power of 21, what should be the last 2 digits? Let's open this in the form of 2 to the power of 10, right? So let's open this in the form of 2 to the power of 10. Why? Because 2 to the power of 10 has got a pattern to it. Great. So this is 2 and this is 2 to the power of 1. Fine. 2 to the power of 10 is what? 2 to the power of 10 is 24. So this is 24 to the power of 2 and this is 2 to the power of 1. What is the meaning of this? This is 24 to the power. It's not important whether it is 2 or 4. The important part is it is what? 76. Why? Because it is 24 to the power of even. Great. So this is 76 into 2. So the answer would be 152 and we can say 52 is the answer. Is it fine, everybody? Is it clear? So this is the answer. So whenever you come across a question, what kind of question? If the power is 2, if the number is 2, whatever the power is, open it in the form of, in the multiple of 10. Because 2 to the power of 10, see these numbers are actually big numbers. So what we are trying to form some pattern. So 2 to the power of 10 can fetch us 24 and 24 has got a pattern to it. Shall we take an example? Let's take one more example. If the question would have been what? 2 to the power of 23. What do you say? What is the answer in this case if we are to find the last 2 digits? What is the answer if we are to find the last two digits in this case? 2 to the power of 23. Well done. Nice. Great. If the question is 2 to the power of 23, what we can do? 2 to the power of 10. How many times? Twice. This is 2 cube. This is 24 and this is 2. This is not important that whether it is 2 or 4. The important part is this is even. That is important. And if it is even, this has to be 76. And what is this? 8. 76 into 8 is 608. So the answer is 08. Is it fine, everybody? Is it clear to all? Right? So I am giving a few questions for assignment. Please complete these questions. So what we can do is, you can complete all these questions. This is 31 to the power of 45 second, 3 to the power of 99 third, 9 to the power of 66 fourth, 7 to the power of 93. This is 93. And furthermore, fifth, 2 to the power of 24 sixth, 4 to the power of 21 seventh, 8 to the power of 21 ninth, 6 to the power of 23. Sir, but you haven't told anything about 4 and 8. Okay? I haven't told you anything about 4 or 8. I have. If the question is 4 to the power of 23, 4 is as good as 2 square. So the entire question pans out like this. We can definitely solve this. Similarly, if the question is 8 to the power of 23, what is 8? 8 is 2 cube and this. Right? Great. And now we can solve this. That's not a problem. So this is 2 to the power of 69. I think we can solve this after that. Right? Is it fine, everybody? Is it clear to all? Is it clear to each and every one of you? So this was how to find the last two digits. Is the topic absolutely clear to each one of you? Right? Great. Well done. Nice. Absolutely. Right? So this was the third topic, the last two digits. Let's write a small note. What is that? What is that small note? The small note is this. For example, if I ask you a number 23, what kind of number is this? This is 2 into 10 to the power of 1 plus 3 into 10 to the power of 0. As simple as this. Why is that so? Because this 2 is face value. And what about this 10? 10 to the power of 0 and 10 to the power of 1. 6 can be written as 2 into 3. Right? Gedila Chandra, what you can do? If it is 6 to the power of 23, what you can do is 2 into 3 to the power of 23. So this is 2 to the power of 23 and 3 to the power of 23. I think this is good enough. Right? So the question is, if it is 23, so what is the meaning of 23? 23 is the face values 2 and 3 and the place value for units digit, tens digit. Units digit is 10 to the power of 0. For tens digit it is 10 to the power of 1. For hundreds digit it is 10 square. Great. And if that is the case, if we interchange these two digits, 3 and 2, if we interchange these two digits, so this 3 is 10 to the power of 1, 2 10 to the power of 0. In this case, this 3 and this 2, they are the face values, and 10 to the power of 0, 10 to the power of 1 are the place values, of course. Because if nothing is mentioned, we are definitely talking about decimal based system. If this is the case, and let us suppose if we are told that you have to form a 2-digit number, fine, let's form a 2-digit number. So what is that? Let us suppose xy is a 2-digit number, right? If xy is a 2-digit number, in that case it is x into 10 to the power of 1, y into 10 to the power of 0. Listen to this very carefully. And if we are to interchange this 2-digit number, if we are to interchange the places of this 2-digit number, in that case, that is, if we are reversing these 2 digits, instead of xy, if we write yx, then what will happen? In that case, this is y into 10 to the power of 1 and this is x into 10 to the power of 0. So, if we have reversed the digits, we can have 10y plus x and this is 10x plus y. And if we are told that the reverse of this 2-digit number and the 2-digit number, the difference between the reverse of this 2-digit number and this 2-digit number is 36. Let us suppose we have been told like this. A storyteller has told that you have a 2-digit number, xy. So, what we've understood from xy, that is important, 10x plus y. And he has mentioned that if you reverse this 2-digit number, that is yx, 10y plus x. The difference between the reverse of the 2-digit number and the actual 2-digit number is 36. If this is the case, and if x and y are natural numbers, then how many possible solutions are there? Yx minus xy, if this is 36. If yx minus xy is 36, then how many possible solutions are there such that x and y are natural numbers? If this is the case, 10y plus x minus 10x plus y is 36. So here what we can see is 10y minus y, basically this is 9y, x minus 10x, 9x. Let's take this. So if this is the case, this is y minus x, 36 divided by 9, what is that? 4. And if x and y both are natural numbers, in that case, I should take this. If x and y are natural numbers, in that case, what will going to happen? 9 minus 5. 9 minus 5 is 4. 8 minus 4 is 4. 7 minus 3 is 4. 6 minus 2 is 4. 5 minus 1 is 4 and 4 minus 0. When you are saying this, it means what are the 2-digit numbers? The 2-digit numbers are xy and the reverse would be yx. Great. So what is the 2-digit number? The 2-digit numbers are 59, 48, 37, 26, 15. 04 is not a 2-digit number. And if 04 is not a 2-digit number, how is it possible 10 minus 6? Can we take 10 minus 6? X and Y are single-digit numbers. You cannot take 10 minus 6. Fine. And then here we can have 95, 84, 73, 62 and 51. All in all, these are the 5 cases. I am explaining this right from the beginning. If a storyteller tells you that there is a 2-digit number xy, then the reverse of this 2-digit number yx, and it has been found that the difference between the reverse of the 2-digit number and the 2-digit number is 36. And if both these numbers are natural numbers, then how many numbers are possible? How many cases are possible? So these are the cases which are possible. Is it fine, everybody? Is it clear to all? So how many cases are possible? The total number of possible cases are 1, 2, 3, 4, 5. This is not possible because 04 is not a 2-digit number. Is it clear to each and every one of you? Is it fine, everybody? Right? Absolutely. So the story was, if x and xy is a 2-digit number and yx is the reverse of this 2-digit number, then the difference between the reverse and the original number is 36. how many probable solutions are there such that x and y are natural numbers. So these are the cases. This question has been asked back to back in your GATE exam, and actually the question was this. The exact question was this. I have given both these questions. This was the question, right? I think you are in this position to solve. Let me take a photograph of this. Let's solve the first one and we'll take the second one as assignment. Both these questions are from your GATE paper, right? We'll take this, let's solve the first one and we'll take second question as assignment. Assignment, it means student dharma. For me, assignment means student dharma. This crash course PDF has been provided the Telegram channel. Please click that. The link has been given to you. And even if you don't have the PDF, I'll share it once again, or I'll either pin it, right? This is the Telegram link. Over here, I have already provided the PDF of this particular session. I've given all the questions, right? Fine, let's take this. The sum of the two-digit numbers is 12. Great. So what has been mentioned is x plus y is equals to 12. And the new number formed by reversing the digit is greater than the original number by 54. Basically, if this is the reverse and this, what is that? 54. Great. Absolutely fine. It basically means y minus x is equals to 6. Sir, why? Because this is 10y plus x minus 10x plus y is equals to 54. Is it fine, everybody? Is it clear to all? Perfect. Great. So what is the answer? If you want, you can go by option as well. That's not a problem, right? So this is the answer. So this is 2y and this is 18. So it means y is equals to 9. And if this is the case, x is equals to 3. So the actual number was xy. So if the actual number was xy, this is 39, and the reverse was yx, so 93. And let us suppose if you had only 10 seconds or something like that, in that case, you can directly check the option. How come? Because xy and yx, this is the original number, yx is the reverse. So this cannot be the answer, that is for sure. Right? 57, so the reverse of 57 is 75. 75 minus 57 is not equals to 12, is not equals to this 54, so rejected. And if you take reverse of this 93, that is not greater than the original number. So the only valid option would have been the first one, even if you have considered directly the options in that case as well. Is it fine, everybody? Is it clear to all? Great. So this was the point. Shall we move ahead? Shall we take one more? There is one more concept. Let's move to the next one. Is everybody fine till now? Everybody fine with all the concepts we've discussed? Right? Shall we move on to the next one? Right? So the next point is factorization. So the next topic is factorization. This is the fourth topic, right? What is factorization? Factorization is when you take any natural number, and after that what do you do? And you break it like this. Is this factorization? No. This is definitely not factorization. Why this is not factorization? And if this is not factorization, then what it is? This is not factorization. So then what it is? These are just factors. Then what is factorization? The factorization is when you write any natural number in the form of its prime factors. When you write natural number in the form of its prime factors. Fine. So, writing any natural number in the form of its prime factors is called factorization. If that is factorization, then why have we even considered this? Just to let you know what these things are and what these things stands for. When you are saying 1, 12, 2, 6, 3 and 4, these are factors. These are mere factors. It means 12 has 6 factors. So, what do you mean when you say the word factor? Factor, it means when you divide 12 by 2, it is divisible. This, the divisor part is factor. So, what we used to call divisor, this divisor is same as factor. Fine. So, this is factor. So, what is factorization? When you write any natural number in the form of prime factors. What is prime factor? A prime number. A prime number that can be written in the form of a factor. Great. So, what these things were? These things are just factors. That's it. So, if someone asks us, what are how many factors of 12 are there? So, this is 1, 2, 3, 4, 5, 6. 6 factors. Absolutely. So, 12 has got 6 factors. Second, can we find the sum of all these factors? First of all, let's understand this in a very manual way, and then I'll let you know something else. So, let's understand this in a very manual way. So, if we want to find the sum of all these factors, 1 plus 2 plus 3 is 6 plus 10, 16, 28. Great. So, this is sum of the factors. The third one is product of the factors. What is the meaning of this word? 1 into 12 is 12, 2 into 6 is 12, 3 into 4 is also 12. So, this is 12 cube. What is 12 cube? 1728. Great. So, this is 1728. So, prime factors, whenever you write any natural number in the form of prime factors, it is called factorization. So, what was this? This was a very layman approach to find the number of factors, sum of factors and product of factors. What we've done over here, we have actually counted the number of factors, sum of factors and product of factors. I think this is clear, right? But every time when you see when this number becomes bigger, when you have a bigger number, in that case it is very difficult to count all these cases. And that is why we need a very standard approach to it. And what is that? We need an approach like this. For example, capital N is any natural number. In that case, let us suppose if I write this number like this. Sir, here what is this A, B and C? This A, B and C are the prime factors. These are the prime factors. Great. Here A, B and C are the prime factors. Absolutely. And P, Q, R are the respective powers of the prime factors. And if we are to find what? If we are to find number of factors, in that case, small n, the number of factors would be this power plus 1, P plus 1, Q plus 1 and R plus 1. That's it. Great. So, shall we take an example? Of course, we should. Let's suppose 12 can be written as 2 square into 3. And if this is the case, we've already counted manually the number of factors of this number 12. How many factors were there? 1, 2, 3, 4, 5, 6. 12 has 6 factors. And in this way, if we are to find number of factors of 12, in that case, number of factors would be P plus 1, that is 2 plus 1. What is 2 plus 1? 3. What is 1 plus 1? 2. So, this is 3 into 2. What is that? 6. Absolutely fine. Is it fine, everybody? Is it clear to all? If we are to find number of factors like this, great, nice. What else we can find? We can find everything, whatever we want. Second thing is, if we want to find sum of factors, in that case it is, this is a to the power of p plus 1 minus 1, b to the power of q plus 1 minus 1, c to the power of r plus 1 minus 1, a minus 1, b minus 1 and c minus 1. Sum of the factors, it means adding all the factors. If we want to find sum of all the factors, this is how we can find. Fine, let's see this, how we can find this, right? So this is, in case of 12, 12 was 2 square into 3. If we want to find the sum, we have already seen that the sum was 28, right? Let's see. In this case, this is 2 to the power of 2 plus 1, that is 2 to the power of 3, minus 1, 3, 1 plus 1, that is 2 minus 1, and then there is 2 minus 1 and 3 minus 1. 2 cube is 20, 2 cube is 8, minus 1 7, and this is 8. 56 divided by 2 is 28. Great. Nice. Let's see the last one. The last point is, if you want to find the product of factors. All these points are very, very important in your paper. All these points are very, very important, right? So, number of factors is equals to product of factors divided by 2, that is it. This. So, this is 12 to the power of number of factors. What was that? Number of factors was 6. 6 divided by 2, that is 12 cube. 12 cube is 1728. Is everybody clear with this? Is it fine, everybody? Is it clear to all? So, this was about number of factors, sum of factors and product of factors. So, this was about number of factors, sum of factors, product of factors. Fine? Shall I discuss? Is it fine, everybody? Is it clear to all? Yes, of course it's clear. Right? Nice. I want you people to find number of factors, sum of factors and product of factors. For what? For all these numbers. Find all these things just for the two numbers, and for the rest of the numbers, we'll take these numbers as assignment. 24, 6060, 9090, 144 and 288. Right? I want the people to find these things for 24 and 288. All these questions are student dharma. We'll do this in assignment part. I want the people to complete 24 and 288. Find number of factors, sum of factors and product of factors, right? For all these three cases, go ahead. Find number of factors, sum of factors and product of factors for all these three cases, go ahead. Great, well done. Anybody else? 24, 288 you need to find over here, and other than that 60, 90 and what is that, 144. These three numbers are assignment. These three numbers, we can solve these three numbers and we can post it on the comment box later on. I want to be able to find these two numbers. What are the numbers? 24 and the other one is 288. What is the very first thing we should do? We should break these numbers into prime factors. That is the most important thing. Great. If that is the thing, let's break it into prime factors. So, this is 2 cube into 3. This is 288, 32. 2 to the power of 5 into 9. So, if we are to find number of factors in this case, power plus 1, 3 plus 1 is 4, 3 plus this 1 plus 1 is 2 and the answer is 8. Second, sum of factors. Sum of factors, this is 2 to the power of 4 minus 1, this is 3 square minus 1, 2 minus 1 and 3 minus 1. This is 60. Let's see the last one. Product of factors. Number of factors divide the natural number, whatever the number is, to the power of number of factors divided by 2. 8 divided by 2 is 4. Is it fine, everybody? Is it clear to all? Is it absolutely fine? Clear. Great. Shall we move on? Fine. Let's discuss ahead. The next part is this. Let's take the first one. Number of factors. So what is that? 5 plus 1 is 6 and 2 plus 1 is 3. 6 into 3 is 18. The second one. Sum of factors. What is that? What is sum of factors? What is sum of factors? Sum of factors is 2 to the power of 6 minus 1. This is 3 cube minus 1, 2 minus 1 and 3 minus 1. Great. What is 2 to the power of the 6? 64, 63 and that's 21, 819. Correct. 63, this is 26, this is fine. Let's move to the last one. The last one is product of factors. 288 to the power of number of factors by 2. Is it fine, everybody? Is it clear to all? Is it clear to each and every one of you? Is it fine? Great, well done. Right? Shall we move ahead? Absolutely. Many a times you come across this kind of question. What kind of question? Like this. For example, I have taken this number 12, right? 12 is a natural number. Let's break it into prime factors. What we can do? We can write it like this, 2 square into 3. If this is the case. If we have been asked, what should be the minimum number? What should be the least number? What should be the smallest number with which this number must be multiplied such that we can have a perfect square? This is a very common pattern. What should be the minimum natural number with which this must be multiplied such that we can have a perfect square? What is the condition to call any number a perfect square? The powers must be, whatever the powers are, these powers, they must be even. That's it. So if this question is 2 square into 3, what should be the least number? What should be the least number with which this must be multiplied? The least number must be 3, of course. Such that we can have 2 square and 3 square. We need even powers, that is it. Is it fine, everybody? If the question would have been for perfect cube, in this case, what should be the least number with which this must be multiplied such that we can have a perfect cube? The number is 2 square into 3 and 2 square into 3. And with which number, with which smallest natural number this must be multiplied such that we can have a perfect cube. For perfect cube, what do you need? You need cubic power. So we already have a 2, let's take a 3. We already have a 3, let's take a 3 square. So that is 2 into 3 square. Such that we can have 2 cube and 3 cube. So this is 3 square is 9, into 2 is 18. Is it clear, everybody? Is it clear to all? Is it fine? Powers must be odd. Powers must be multiple of 3. That is important, right, Shali? It means that whatever number has been given to us, what you are suggesting, for example, if the number is 48, the very first thing that you are suggesting is break it into prime factors. Absolutely. What is 48? 2 to the power of 4, 16 into 3, into 3. What should be the minimum natural number with which this must be multiplied such that we can have a perfect square and a perfect cube. Find the answer of both these questions such that we can have a perfect square and a perfect cube. Go ahead. What is the answer? What should the answer be? What should be the answer be? What should be the minimum number with which this must be multiplied such that we can have a perfect square and such that we can have a perfect cube? Absolutely. Nice. So, if it is a perfect square, in that case, the number is already 2 to the power of 4 into 3. What we want an even power, that is it. And to have an even power, what we can do, we can directly multiply this by 3. On the contrary, in this case, we already have 2 to the power of 4 into 3. We want the powers to be multiple of 3. And if this is the case, this must be 2 square into 3 square. Is it fine, everybody? Is it clear to all? What is 2 square? 4. 3 square is 9. 9 into 4 is 36. Exactly the very same question has been given to you in your gate paper. What was the question which was given to you? This was the question. This. This was the actual question which was, this was the actual question which actually came in your gate paper. What is the answer? I want you people to find the answer for perfect square and perfect cube. Although they have asked only for perfect square, I want you people to find first for perfect square and then for perfect cube. I want you people to find for perfect square and then for perfect cube. Then for perfect cube. I think you are in this position to find the answer of both these questions. Go ahead. Great, well done. Rest of the people, make it fast, please. Rest of the people, make it fast. Nice, nice, nice. Great. I want both these answers. Perfect square and perfect cube. The very first thing that we should do is we should factorize it. What number? The number is 62. 162. 2 into 81, right? So this is 2 into what is 81? 3 to the power of 4. So these are the prime factors. And once you've got the prime factors, now it is very easy. So what should the answer be? The answer must be, the number is already 2 into 3 to the power of 4. The number is already 2 into 3 to the power of 4. So in case of perfect square, we need to multiply this number by 2 and this is the answer. On the contrary, in this case, we need to multiply this by 2 and 3 square. That's it. So these are the two answers. Is it fine, everybody? Is it clear to all? Is it absolutely clear? Right? Great. Well done. Fine. Shall we move ahead? Right? Fine. Great. I think we should. Right? At times, what happens, they ask a very specific kind of question. What is that? We have seen that 12 has got these many factors: 1, 12, 2, 6, 3 and 4. Right? These are the factors. So 12 has these many factors. Right? If we are asked, if we have been asked that, no, not this. What we have been asked, like this. Let's take a smaller example. If we have been asked that, out of all these factors of 12, how many factors are there? There with what? How many factors are there which are divisible by 2, divisible by 3, divisible by 4? Now listen to this. When can we say any numerator? Let's take a very basic example. When can we say any numerator, irrespective of the fact what the value of the numerator is? Any numerator whatsoever the numerator is divisible by 2. When can we say any number, any numerator, any natural number is divisible by 2? The prerequisite condition is that number must be, this number must be what? This number must be even. Similarly, if we are to find those numbers which are divisible by 4, the basic, divisible by 3, the basic idea is any numerator or any natural number is divisible by 3. What is the prerequisite condition? It must have at least a 3, 1 3. For example, if the value of this number is 12, so 12 is basically 3 into 4. Is 12 divisible by 3? Yes, of course. As long as the numerator has got 1 3, right? So this is what I am saying. If it has been asked, this question hasn't been asked in your GATE exam, but I believe it's a very, very important concept. If it has been asked that out of all these factors of 12, how many factors are divisible by 2, 3 or 4? 3 separate questions. Now listen to this very, very carefully. What we know, this 12 is 2 square into 3. When can you say any number is divisible by 2? That number must have at least 1 2. Take that 2. Okay. If you take 1 2 from here, what is that we are left with? We are left with this. Great. Sir, what have you done over here? I have taken 1 2 from here. Sir, why? I'll explain that. And if we are to find number of factors, so this is 1 plus 1 2, 1 plus 1 2, 2 into 2 4. If you want, you can cross check it. How many factors are there? 1, 2, 3 and 4. Great. How many factors of 12 are there which are divisible by 3? This is what I am saying. If you want to find all those factors of 12 which are divisible by 3, take 3 from here, because that number must have at least 1 3. And if this is the case, this is what we are left with. Sir, left with from where? From here, 2 square and 3. We have already considered, we have already taken this 3 and this is what we are left with. And if we are to find number of factors, in this case 2 plus 1 is 3. If you want to cross check it, this is the answer. This is 3, 6, 12. How many factors of 12 are divisible by 4? You can take this 2 square. 4 is basically 2 square. What is that you are left with? 3 to the power of 1. So 1 plus 1 is 2. Sir, although I have understood this, but still I have some doubt. I'll explain this once again, don't worry. Listen to this very carefully. I am explaining this one. I am about to explain this. I am about to explain this. Fine, listen to this. Listen to this. If we are to find all those factors of 12 which are divisible by 4, right? Sir, you are suggesting that whatever prime factors it has got, fine. If you want to find all those factors which are divisible by 4, take this 4. Absolutely. Whatever the numerator is, if you are saying that that numerator is divisible by 4, that must have a 4. So what we have done, we have taken this 4. And now after this, what is that I am left with? I am left with 3 square, 3 to the power of 1. What is the meaning of this? This is what it means. You can have a 3 if you want, and if you don't want, don't have a 3. Maximum you have this 1 3. because you have already fixed this 4. So this is 4 into 1, that is 4, and 4 into 3 is 12. These were the two numbers. Is it fine, everybody? This was the first number and this is the second one. Sir, can we take this example? Of course we should. Let's take this one. If we want to find how many factors of 12 are there which are divisible by 3, first of all consider this 3 and fix this. Fine, let's fix this number 3. Those factors which are divisible by 3, they must have at least one 3. Let's fix this 3. So what I've done, I've taken this 3. What is that now you are left with? I'm left with 2 2's. It means at max I can use 2 2's. If at max I can use 2 2's. What does that mean? If I don't use this 2. 2 to the power of 1 and 2 square. What is the value? This is 3, this is 6 and this is 12. Now is it fine, everybody? Absolutely very easy, I guess. Right? The point was, whatever the numerator is, if it is divisible by 4, it must have a 4, as simple as this. So sir, you mean to say that the prime factors, what are the prime factors of 12? 2 square into 3. Fix this 4 first. And then what is that you are left with? 3. 3 to the power of 1. What is the meaning of this? At max you can have 3 to the power of 0, or at max you can have 1 3. Similarly, if you want to find all those factors of 12 which are divisible by 3, fix this 3. At max you can use 2 2's. So either 0 2, 1 2 or 2 2's. Now is it fine? I think it is absolutely fine, right? Let's take one more example. Let me take a few more examples first. Sir, let us suppose if we have a huge gigantic number like this, 2 to the power of 3, 3 to the power of 4, and what is that, 5 to the power of, let's take one more, 4. And if we want to find all those numbers, which are divisible by what? If we want to find all those numbers are divisible by, all those factors are divisible by 8, which are divisible by 81, which are divisible by this 25, 625, which are divisible by 100. That's not important. The important thing is, you want to find all those numbers are divisible by 8, break it into prime factors. What is 8? 8 itself is 2 cube. Take 2 cube from here. What is that you are left with? I am left with what? I am left with 3 to the power of 4 and 5 to the power of 4. That is it. Find n. So this is 4 plus 1, 5, 4 plus 1, 5. What is the answer? The answer is 25. Is it fine, everybody? Now is it clear? Is it fine? Is it absolutely clear to each one of you? 81. I don't recognize 81. What is 81? 81 is 3 to the power of 4. Take 3 to the power of 4 from here. If that is the case, what is that you are left with? You are left with 2 cube into 5 to the power of 4. Find n, that's it. Find n in this case, man, that's it. 3 plus 1 is 4. 4 plus 1 is 5. 5 into 4 is 2020, that's it. 625. Very easy. 625 is basically 5 to the power of 4. Take 5 to the power of 4. What is that you are left with? I am left with 2 cube into what? 3 to the power of 4. Right? 3 plus 1 is 4. 4 plus 1 is 5. 4 into 5 is 2020. 100. What is this? 2 square into 5 square. So what is this that we are left with? 2 square. I am left with only 2 to the power of 1, 3 to the power of 4 and 5 to the power of 2. Find number of factors. So 2, 4 plus 1, 5, 2 plus 1, 3. Ultimately, what is the answer? The answer is that. Is it fine, everybody? Now is it clear to each one of you? I think this is clear now. Is it fine? Right? I think it is clear to each and every one of you. I think it is absolutely fine. Right? I have given this kind of question in the booklet as well, in the sheet as well. You can you may download this sheet from the Telegram channel. I have already shared this. I'll pin this later on after today's class. So I have given enough questions. For example, if you see, I have given this. Where is the question? This question number 5th and 6th. Can we do these two questions? Right? I think these two questions are now doable. We'll do this. We'll solve this later on. Right? Solve these two questions and you can post the answers in the comment box. Right? Later on, once this video will be there, once this video will be available, you can solve these two questions and you can post it in the comment box. Is it fine? Right. Shall we proceed ahead? Let's take one more example. Let's take one more small note. Right? What is that? Let's take a very small point. What is that? The divisibility rule of 3. What is the divisibility rule of 3? Digit sum. If digit sum is divisible by 3, the number must be divisible by 3. If n is a 4-digit number and if we are to find whether n is divisible by 3 or not, if we are to find whether n is divisible by 3 or not, what we are supposed to find, what we can do is, if a plus b plus c plus d, if a plus b plus c plus d, that is the digit sum, if it is divisible by 3, the number must be divisible by 3. Is it fine, everybody? Yes, of course. If the digit sum is divisible by 3, the number must be divisible by 3. If the digit sum is divisible by 9, then the number must be divisible by 9. Is it clear? Is it fine, everybody? If the digit sum is divisible by 3, the number must be divisible by 3, and if the digit sum is divisible by 9, then the number must be divisible by 9. Great. For example, if we are asked 1, 2, 3, 4, 5, is this number divisible by 3? Is this number divisible by 3? Right? If we are asked 1, 2, 3, 4, 5, if this number is divisible by 3. Right? So what we can do? Either we can find the digit sum 1 plus 2 plus 3 plus 4 plus 5. What is the digit sum? The digit sum would be 15. And we can check that whether this number is divisible by 3 or not, and based on this we can categorically mention that yes, indeed it is divisible by 3. Of course we can do that. That's not a problem. Right? That is not a problem. But we can also solve it like this. Yes, we are doing the very same thing, but instead of adding all these numbers, we can use distributive law. How come? 3, 5 plus 1, 6, divisible. 4 plus 2, 6, of course it is divisible. Is it fine? So 3 is divisible, 5 plus 1 is 6, 2 plus 4 is 6, yes, absolutely. Right? It means that, sir, you are saying that 9, 8, 7, 6, 5, 4, 3. If I am to find whether this number is divisible by 3 or not. Sandeep, if you keep on spamming, I'll block you. Fine? The PDF note is available in the Telegram channel. Please don't spam. So 9876543. If this number is this number divisible by 3, right? If we want to find whether this number is divisible by 3, instead of adding all these numbers, what we can do? This 9 divisible by 3. This is 3 divisible by 3. 5 plus 4 divisible by 3, of course. 6 is divisible by 3. 8 plus 7 is 15 divisible by 3. That's it. Fine? Is it clear, everybody? Is it fine? I think this is absolutely fine. Right? So 9, 8, 7, 6, 5, 3 this. Many a times we come across these kind of questions. What kind of questions? 9, 8, 3, 2, 7, 6. Is it divisible by 3? Let's see this first. So this is 9 is divisible by 3, 6. 7 plus 2, yes, 3, yes. But 8, this is what we are left with. Now in this case, they'll ask us what should be the minimum value. We can write over here such that the number becomes divisible by 3. What should be the number? What do you say? What should be the minimum number I should write over there such that this numerator becomes divisible by 3? Let's see. So this 9 was divisible by 3, 3 is divisible, 7 plus 2 is 9, 6 is also divisible. Now this is 8, 8 plus 1, absolutely. So this is the answer. So this is the answer. Sir, what will happen in case of 9? If 9 is the case, if we are trying to find the answer for 9, in this case, same digit sum must be divisible by 9. Instead of adding and aggregating all these sum, the number, what we can do, 8 is divisible, great. 6 plus 3 is 9, great. 5 plus 4 is 9, absolutely fine. Now what is that we are left with? 8 plus 7 is 15. So what should be the minimum number I should write? What should the minimum number I should write over here such that the number becomes divisible by 9? Go ahead. 8 plus 7 is 15. So what is that? What should be the minimum number I must write over here such that the number must be divisible by 9? Absolutely correct. Yes. So what is the answer? The answer must be 3. Is it fine, everybody? Is it clear to all? Sir, we can expect these kind of questions to GATE exam? Of course you can expect it. Of course you should expect. This is what they have asked. These are the most of the questions I have taken in this PDF are the ones which I have actually asked in a GATE exam. This is the one they have asked. This is the one they have asked. Find the answer of this. I want you to find, let me write this, 7, 1, 5, blank, 4, 2, 3. What should be the minimum digit such that this number must be divisible by 3, and one more case, 7, 1, 5, blank, 4, 2, 3. Such that the number must be divisible by 9. Fine. I want to be able to find both these answers. What should be the minimum value such that the number must be divisible by 3 and such that the number must be divisible by 9. Go ahead. Great, well done, nice. So this is 7 plus 2, 9. 5 plus 4, 9, and this is 3. What is that? We are left with 1. So what should be the minimum value? 2. Great. We have got the answer. The answer to this question is 2. Absolutely. On the contrary, if we have been asked with the very same question, but if we are asked that what should be the minimum value such that the number must be divisible by 9. If this is the case, 7 plus 2, 9. 5 plus 4, 9. This is 3 plus 1, that is 4 plus 5 is 9. Is it fine, everybody? Is it clear to all? Right? Is it clear to all? I think it is absolutely clear. Right? It is absolutely clear. I think this is clear to each and every one of you. Let's take the very last point. And what is that? Fine. Shall we move ahead? Shall we take the last point? Shall we take the last point? This is the last point. Right? This is the last point. A small note. What is that? Total number of single digit numbers. Total number of single digit numbers, it means from 1 to 9. Total number of single digit numbers are 9. from 10 to 99. Total number of double digit numbers are 90. From 100 to 999, total number of triple digit numbers are 900. Great. So total number of single digit numbers, total number of double digit numbers, and total number of triple digit numbers. Listen to this very carefully. So it means total digits would be 0, 9. And when I said 0, 9, what I meant 1, 2, 3, 4, 5, 6, 7, 8, 9. This is what I meant when I said total number of single digit numbers are 9. This is what I meant when I said total number of single digit numbers are 9. Is it fine? Of course. Right? Let's move to the next one. 10, 11, 12, 98 and 99. What is this? These are the total number of double digit numbers. When I say total number of double digit numbers, this is what I meant. 90 this into 2, 180. It means that right from the beginning till here, how many digits have I written? 09 plus 180 is 189. Is it fine? I think it is absolutely fine. It is absolutely clear, right? Then, total number of 3-digit numbers. Total number of 3-digit numbers. Starting from 100, 101 till 999. So total number of 3-digit numbers would be 900 this into 3, that is 2700. It means right from the beginning I have written 09 plus 180 plus 2700, that is 2889 digits. This is the last point. We will take a few examples and then this will be the last point. So, total number of single digit numbers would be from 1 to 9, 9. Total number of double digit numbers from 10 to 99, 90. Total number of triple digit numbers from 100 to 999, 900. How many digits? Total number of digits. 9 into 1 would be 90. 90 into 2 would be 180. 90 into 3 would be 2700. When I've written this, this is what I meant. This is what I meant. Is it fine, everybody? Is it fine, everybody? Is it fine? Great. It means that if someone asks us what will be the 25th digit, forget about the 25th digit. What is the 25th digit? Forget about that. Where it will lie? The first 9 digits will lie here. After this, right at the stroke of 10th digit till 189th digit, all the digits will be here. Immediately after this, it means 190th, 191st, 92nd till 2889th digit, all the digits will be here. Is it fine, everybody? The first 9 digits, after that next one 80 digits. It means starting from 10th digit. What would be the 10th digit? The 10th digit would be this one. 11th, 12th, 13th, 14th, 15th, 16th and so on. 189th, 188th, 187th, 186th and so on. Great. It means that if we are asked to find the 25th digit, if all the natural numbers are written side by side, starting from 1, 2, 3, 4, 5, 6 and so on. if all the natural numbers starting from 1 are written side by side, and we are to find what? The 25th digit. What we know? We know that the answer cannot lie in the first 9 digits. The answer cannot lie in the first 9 digits. And because this is not symmetrical, these are single digit numbers, double digit and triple digit numbers. So we have subtracted these cases because we know after these 9 digits, all the numbers right from the 10th till 189th will be double digit number, right? Is it fine? So this is what I am left with. I am running short of 16 digits. Is it fine, everybody? But we also know that after 9, all the digits, all it means from 10th till 189th, all the numbers are double digit numbers. It means 9 plus 8, 17. So 7 of 17 will be the 25th digit. Is it fine, everybody? We need to install Telegram first and then open the link, then it will be open. Sajan saying first install Telegram and then open the link. 1, 2, 3, 4. This is 10, 11 and 16, 17. Is it fine, everybody? So what is the answer? This 7 is the answer. This is the 25th digit. This is the 25th digit. This is not at all a bad way to answer. If we are to find 25th digit, what we know, the 25th digit cannot lie in the first 9 digits. So we have subtracted it. So we have subtracted the first 9 digits. Other than this, what we know, till 189th digit, all the numbers are 2-digit numbers, and that is why, sir, what this X is? All those numbers. And what this is? Post this 9, all these numbers are 2-digit numbers. So our answer lies somewhere over here. So X into 2, every single digit will going to have 2 digits. Every single number will going to have 2 digits. X into 2, how many digits are we running short of? 16. This must be equals to 16, so 16 divided by 2 is 8. So this is 9 plus 8, 17, that is 7. Is it fine, everybody? Shall I take one more example? Let me take one more example in that case. Let me take 100th digit, you can do this. Let me take 100th digit, right? SSG and Rahul, listen to this. If you want to find the 100th digit, our 100th digit cannot lie in the first 9 digits, and that is why we have subtracted this. So how many digits are we running short of? We are running short of 91 digits. Rahul, is it clear? Is it fine, everybody? We are running short of 91 digits. Is it fine? So because we are running short of 91 digits and post this 9, that is 10, 11, 12, 13, 14 till 189th digit, all the numbers have 2 digits. So this is 91. So this is 91 divided by 2. When you divide this, what you will going to get? You will going to get 45 numbers and what else? 1 remainder. What is the meaning of this? It means 9 plus 45 is 54, and this is the first digit of 55th. That is 1, 2, 3, 53, 54 and 55. This is the first digit of 55. Now is it fine? After 189, of course, we'll take, what will take? 3 into x, of course. Shweta Pal. For example, if you are to find 200th digit, Shweta, what will you do? If you are to find 200th digit, Shweta, what will you do? In that case, subtract. Instead of subtracting 9, directly subtract 189. Right? Fine? Is it fine, everybody? So 11 digits. This is what we are left with. So this is what we are left with. 11 digits. Is it fine, everybody? Is it fine? 11 digits. Is it fine? So this is what we are left with. 11 more digits we are left with. So x into 3 is 11. X is equals to 11 divided by 3. Fine? So we are running short of these 3 more numbers and then 2 digits. Fine? Okay? Is it fine? Is it clear, everybody? Is it clear to all? I think it is clear, right? Great. ये जो सब फर्जी अकाउंट वाले आते हैं ना इधर उधर से, मेरे को लीगल भी उतना ही आता है, मेरे को सिर्फ ये सब नहीं आता है, मेरे को लीगल भी उतना ही आता है. तो ये फरहान वरान ये सब जो होंगे ना, तो जहाँ ढूंढ के बैठा वो वहीं से निकलवा दूंगा. आईपी एड्रेस निकलवा के इतने सारी मैं डिफेमेशन की केस लगा दूंगा कि जो फर्जी अकाउंट सब बंद हो जाएगा. ठीक है? सो ऐसा नहीं कि मुझको सिर्फ पॉलिटी इकोनॉमी और ये सब आता है. आई नो इनफ लीगल and I'll put you, I'll make sure I'll put you behind the bars. I know enough defamation cases and I know enough defamation and libel laws as well. What is required? IP address is required. That is the maximum thing that is required. You must be in India or Asia, right? India, which corner of India you are sitting? I'll find it out, don't worry. So don't put all these nonsense. Fine, so this is the answer. Is it fine, everybody? Is it clear? Is it clear to all? Fine, so this is the answer, right? Remainder 2 is 2 digits. Listen to this. Listen to this. This is 3 numbers and these are the 2 digits after what? After what? 1, 2, 3 and 89, 189, it means, where is that? See this is the 189th digit, right? And then followed by this 3. Where is that? This. So when you are saying that after 99, these are the 3 numbers, 100, 101, 102. After this 98, 99, 100, 101, 102, right? So this is second digit, it means 103. So this is the second digit of 103. This is what it means. Fine? I think it is clear now. After 99, we need 3 more numbers, 100, 101, 102. And the second digit of 103. Is it fine, everybody? Is it clear to all? Is it clear to all? So this was the second class and this is what I'm done with. So I do believe that you have understood every single point. So we are done with almost 5 concepts from the very first topic. Although I have shared this PDF, in the Telegram, but I will share this once again and I will pin this, right? So sir has already shared the Telegram link. Please install Telegram and download this booklet, right? We're going to meet in the next class and that will be tomorrow. So the next class will be tomorrow at 1:30. Fine. So we'll meet at 1:30 tomorrow. Okay. Fine. Bye everybody. Take care. Jai Hind.